the first example is 771. Okay, in this it has asked us to write an AVR C program to send values 0, 0 and FF to the port B. So it's just a simple code. In this, what we have to do is we are using hashtag include AVR. Okay, that's the starting of the C code, and then we're using int main, and here we are assigning Z as an unsigned char, unsigned character, and then we are assigning 0xFF, means the initializing to the DDRB pin, and we are using here for loop that Z is equal to 0 and Z will continue to 255. So what's in this code is that in this the program never exists for the for loop, because if you increment an unsigned character variable when it is 0xFF, it will become 0. So what will this happen is you are initializing from 0 to 255 by using unsigned char, and then this is increment, and we have signed Z as a Z on port B. And 2, that is write an AVR C program to send hex values for ASCII characters for 0, 1, 2, 3, 4, 5, and A, and B, C, D to the port B. So what we're gonna do is in this we are using hashtag include IOStream, and then after that we're using the main, and in this we are actually assigning char my list is equal to 0, 1, 2, 3, 4, 5, 6 ABCD, means this is from 0 to 15. Okay. So here we're sending 0xFF to the DDRB pin, and before that we are assigning Z as unsigned char, and we are using here a for loop, and in this Z is equal to 0 and Z less than 10, and Z increment, and then we are setting my list Z at port B, and we are using while needed if running on a trainer. And because we are actually running this code on trainer, so we are using this while, and then we're returning it. And in this next example, it says that write an AVR C program to toggle all the bits of the port B 200 times. Okay, here what we're gonna do is we're actually toggling the bits of port B to 200 times. Okay, so let's start from this. We are using hashtag include IOStream, hashtag include avr.io.h, and then this in main void, and then after that DDRB is equal to 0xFF. Then after that we are actually signing 0xAA, that is 10101010 to the port B. Okay. In next we are assigning unsigned char character to Z, and then we are using for loop, because we want to run the line 200 times, so we are setting Z to 200. We go from 0 to 200. Then port B, we are setting port toggling the port B, so we're gonna set it on the port B, and we are using here. So moving on to our next code, that is example 9. Okay, what's in the next example? So let's see here. So they're saying the LEDs are connected to the pins of port B, and they are asking that write an AVR C program that shows the count from 0 to FF and 00000 to 1 in binary on LEDs. So starting from the hashtag include avr.io.h, we are actually defining here the CPU. Okay, because we are actually now dealing in binary, so we're gonna use 16 mega UL, and then after that we're using hashtag include until delay.h, and in main and void. In this we are actually assigning port B as output, that is 0xFF, and we are assigning it as DDRB, and then we're using while 1. And after that, what we are using is port B is equal to port B plus 1, and in this we are using setting delay MS 500, and that's it. That is 7.11. that what we're gonna say is, so they were saying that write an AVR C program to get a byte of data from the port C. If it is less than 100, is less than 100, send it to the port B, otherwise send it to the port D. So what we're gonna do is has to include avr.io.h and thus into main, and ddrc we're gonna assign as 0, and after ddrb as 0xff means port B is output, port C is input, and in this port D is also output that we are assigning as 0xff. Well, now what we're gonna do is we're using unsigned character, temporary, and while temp is equal to we are read, actually setting that read from pin C. Okay, we are setting that. So we are doing that. Yeah. So we are using if loop here. The if temp is less than 100, it will go to the 100, and then the port B is equal to temp, else port D is equal to temp. And we are then returning 1.12, then we go to 7.17. That is saying, let's see what it's saying that. Yeah, that's the 7.17. That's saying that I write an AVRC program to read the pins 1 and 0 of the port B and issue an ASCII character to the port D according to the following label. Okay, this is the label that they are giving to us. Okay, now let's see the solution. What's the solution here? So it's using to include standard AVR header, and after that into main and unsigned character. So here they are making port B as an input, and then setting it to 0, and then port B as an output and setting it to 0xff, and then while for repeating forever. Then they are using Z as read port B. So port B is actually reading by using Z, and then we are here in this code we are actually masking the unused bits. What the fuck is doing is that Z and 0B00011, and we are going to mask the unsigned bits. Okay, and after that we are using switch Z that to make the decision from all these cases. So what it depends on the input, what's the input, and we're gonna make the decision from all these 4 cases. So the first case is very simple. In first case is case 0, that's saying that port D is equal to 0, is issuing the ASCII 0, and after that the case 1 says that port D is equal to 1, okay, issuing the ASCII 1, and after that case 2 saying that the port D is equal to means the issuing the ASCII as 2, and in case 3 the port D is equal to 3 and it is issuing the ASCII as 3. So next code, that is 7.24. Let's move on to our next code, that is 7.25. So saying here is a door sensor is connected to the port B pin 1 and LED is connecting to the port C in pin 7, right? And AVRC program to the monitor to door sensor, and when it opens, change so we're using standard AVR header here, and after that LED 7 and defining sensor 1. So because we are actually using output, these are the outputs that we are actually using it, so we have to define them. Again, it's gonna hurt. So int main void ddrb. So actually here what we are doing is sensor pin is input, means the sensor pin is input. So what we're doing is ddrb is equal to 1 less than sensor. So actually we are getting sensor as a pin input, and after that the ddrc is equal to 1 less than LED. LED is actually the pin is output. So moving up forward, what we're again doing is if pin B, checking the sensor pin of pin B that whether it's working or not. So we are using here the if condition. We say that pin B and 1 less than sensor. So in the next line it says that port C is equal to 1 decrement LED. So here actually we are setting the LED pin of 4C. So this was the if condition. In else condition, what we are doing is we are setting 4C as a clear code, and moving forward, let's move on to the example 727 says something different. So 727 says that write an AVR C program to convert ASCII digits of 4. Okay, ASCII digits of 4 and 7 to packed BCD and display them on port B. So what they are saying that we have to convert ASCII digits 4 and 7 to the packed BCD, and then we have to display them on port B. It's very simple. We're gonna what's the game plan here is we're gonna assign these two characters 4 and 7 to some alphabet, and we're gonna call them. Okay, so using hashtag clear standard AVR header int main unsigned character BCD type. Actually we are here using the BCD type, and then unsigned character W is equal to 4. We have actually signed 4 as W, and then unsigned character C is equal to 7, and after that DDRB is equal to 0xFF. So actually we are making port B and A output. So next is W is equal to W and 0xF 0F. That's actually masking 3. We are actually doing masking 3 here. So in that here W is equal to W less than 4. In this we are shifting left from left to make upper BCD digit, and after that is equal to Z. And so what we're doing is making a masking 3 here also, and then after that BCD